Okay, so in the last class, we ended while talking about the process of decoding, right? So let's do a quick recap of where we are, right, and then continue from there, and we'll just set the stage for why we are talking about decoding, right? So far what we have done is we looked at transformer as the function, right, which takes the input, okay, and then it starts generating the next tokens after that, while auto-regressively, that means it takes its own output as input at subsequent steps and it generates the output, right. And during training also, of course, we have trained it in this manner because we showed it certain text and then we knew what the next word was and we asked it to predict that and then back propagated the loss depending on the probability of the maximum token, right, the negative log likelihood. So during training, it has been trained on tons of such data where you showed it some context and asked it to predict the next. And now this idea of next token prediction, you can iteratively stretch it to generate as many tokens as you want and maybe even generate full stories, right. So that's what we are trying to discuss at the end of the last class, where now I have this trained, pre-trained transformer, okay, and now suppose, because later we will talk about instruction fine tuning also, where we will also train it on such specific tasks that, hey, can you generate a story which starts with once upon a time, right. So that becomes the input that is given to the model. Can you generate a story which starts with once upon a time, right. So this entire thing has become the first k tokens given to the model, and from this point onward it has to start generating the answer, right. So you could think of that also as just constantly predicting the next tokens till you are satisfied or till you reach an end of sequence. So you have started generating the story, and once you have reached the end, that's where you will stop, right. So you could have a special end of sentence or end of sequence marker. Whenever you see that, you know that the answer is now complete, right. So the main idea I am trying to convey here is that given how the model has been trained to predict the next tokens, and something additional that we will do in what is known as instruction fine tuning, now we would want the model to work in the following scenarios where I have given it certain input, right, and it has to start continuing the answer from there, right. So that's any problem that you look at, you could map it into this framework. For example, I have asked a question and it has to start generating the answer. I have given it the paragraph and said, can you summarize it, and it has to start generating the summary, right. So everything you can think of, whatever input you have given as the first k tokens, and from that point onwards it has to generate the remaining tokens, right. So that's one way of looking at it. So now given this context, right, this is what the wow factor is. Before this, what we did was we talked about pre-training the model and we talked about fine tuning the model on specific tasks like predicting positive, negative or neutral sentiment, or trying to see whether two sentences are related to each other by entailment or not. Those are quite, I would say, easier in certain ways as compared to what capacities or what capabilities we see in modern LLMs, where given very arbitrary creative tasks designed by users, right, as opposed to these academic NLP tasks which have existed for many years, very creative tasks that write a poetry on Linux which starts with Windows, right. You give it a very specific prompt and it generates a poetry from there, right, at least the more powerful LLMs, right. So those are the kinds of things which have wowed us, and we would like to see what, how does this decoding work, right. So how does it, of course not how, I mean, how is it produced, how is it able to produce such a good output, that of course we don't know because we are not fully aware of the training details of many of these models. But what do you mean by decoding, right? Once you give it an input, what happens next, right? So that's the process that we are trying to understand. So this was the simple fine tuning for standard NLU or NLG tasks. Now we are thinking of decoding, where I have the trained transformer and I start with something simple like I like, and I want it to produce the rest of the sequence, right. Not anything fancy, I am not asking you to write a poetry or to write a story or anything, just complete this sequence. So it's simple sequence completion, and this is exactly the task on which it has been trained during pre-training. You gave it some parts of the token, it has to predict the rest of the tokens, right. And we also understand this iterative nature, where it will predict the third token, take the first 3 tokens as input now, predict the 4th token, take the first 4 tokens as input now, and so on, continue, right. So that's the process that we are interested in. And the comment that we were making at the end of the lecture was that we would not want incoherent responses, we would not want degenerative responses, repeated responses, and we would like to see some variety, right. Every time I give it the input I like, if it just says to read a book, there is no creativity there, right. We would like it to generate different outputs at different times, right. So how do you do that, right? And one thing that we briefly touched upon is that at least if we just take the maximum probability token at every time step, then no matter how many times you feed the word I like, it will always generate the same sequence following there, right? Because there is no stochasticity in the model, it's all deterministic. You gave the input I like, all the computations in the network are deterministic because they are just additions and multiplications, and at the end you will get a distribution, whatever was the maximum value on that, no matter how many times you do this computation, that will not change, right? So the third would be 2 no matter how many times you do this computation, and from there on everything else would be the same, right? So what we're going to look at today is a few decoding strategies which will hopefully help us ensure the variety in the output, right? So that's the goal that we want to address today, okay? So there are quite a few decoding strategies. There are deterministic, as I said, that every time the same output would be generated. Then there are stochastic. Within deterministic, deterministic, there would be exhaustive search, there would be greedy search, there would be beam search, and something known as contrastive decoding. In stochastic, we look at top K sampling and top P, which is also known as Nucleus sampling, right? And hopefully the stochastic sampling approaches will allow us to generate different outputs based on the same prompt, right? So that's where the stochasticity might come in, okay?